working, please sit together with whoever's laptop is working. So we're going to cover some basics of value at risk models quickly and one example of calibration, and then we'll jump into EAD and CVA for an IRS portfolio. Yeah. So the first thing which we need to do is we need to load the relevant libraries, and if they are not already loaded, you need to first install them, right? So this is an online version. So a few libraries you need to actually install before you start using. Yeah. So the way we do it here is you can write pip install, pip space install, and whatever library you want to install. For instance, if I want to use Yahoo Finance, I can just write this and click on this. Yeah, so Y Finance is a library where you can download online data like stock prices, etc., etc. I'm taking a simple example for VAR calculations, right? So once it's ticked, it means that statement has been compiled and run. You can keep on clicking code plus here at the top so that there are more lines within. Yeah, so the first step is installation of the library, which is Y Finance, Yahoo Finance. So this is case sensitive. Y with a capital N. Next thing is after installation, you need to load this file into the memory or this library. So we write import Y Finance as YF. So now wherever we want to reference Y Finance library, we are going to reference is using the YF dot handle. Yeah. So for instance, if I want to download, I can write YF dot download. So we're just creating an object here, and we are calling the method. To do is to download the data, to fetch the data online. So I write data equal to, you can write any name. It's a variable name on the LHS. You can use any name there. So data equal to YF dot download. And as soon as you start clicking YF dot, it will show you the various methods which you can use, or functions which you can use. So since we're interested in downloading, we'll use this function called as download. Open bracket. First thing is the ticker. The way this works is as soon as you go into the parenthesis, you will understand what to input, right? So it automatically pops up and it tells you what to input. So the first thing which we need to input is one ticker or a collection of tickers. Then the start date, end date, and maybe some other things could also be included. We'll keep it simple here. So we'll say, okay, let's do YF dot download on maybe ticker SPY, which is S&P 500. Start equal to, we need to provide the date there. So you can write 2020-0101. And then the end date equal to, in double quotes, 2022-0630. I've also provided a file to you called as VAR model. So if you're stuck anywhere, just go to that file, just copy the line from there. Yeah. So once we run it from here, so there's a green tick, which means it's executed properly. So to understand what this is, if you want to understand how many rows, how many columns, just do data dot shape or whatever variable you've used dot shape. So it tells us that there are 628 rows, so 628 dates, and there are 6 columns. So how does the data look like? We just type data, and this is how the data looks like. So once again, we used yf.download in order to download the data relevant to this symbol. Start and end date is also provided. Data.shape is telling us how many rows, columns, basically what are the dimensions of this data set. And then to just print the data, either you can do data or you can say print data. No? Who's done? So one thing which we note is if you see, very strangely, it's showing us 6 columns, correct? But if you look at the data set, how many columns you see? Actually, you see 7 columns. And the reason behind that is the first column, which is date, is not considered as a column. It's considered as a key or an index. So every row is indexed. And in this case, the index is nothing but the date. Yeah. So typically, what we need to do is whenever we download data from Yahoo, generally we have to reset the index. So for that, we have to use a method called as reset_index, which basically takes this date out, puts it as a separate column, and then replaces that with numbers 0, 1, 2, 3, 4, which means number 0 is for row 1, number 1 is for row 2, and so on and so forth, right? So after this, what you can do is just type data dot. So as soon as you start typing data dot, it should tell you what things you can do with that. Yeah. So what parameters can be used, what methods, what objects can be called upon. So I say data dot reset_index. And as soon as I start typing, it shows me. So you can just press tab to complete. So reset_index. So we have to say in place equal to true, which means that in the place of the key column, have the key column, but replace it with numbers, basically. Yeah, so whatever was the original key column is being retained as a new column. Yeah. So I'm just going to press enter here and just now click on the data, type data. And if you see, date column has moved from the key column onto an actual column here. And the key column is 0, 1, 2, 3, 4. So reset_index is a simple function which helps you convert a key column into a column. So it's not a key column, it's a key. So that is converted into a column. And now if you check the data shape. So if you just write data.shape and check its dimensions. So now from 6, it's gone into 7, which means the new column created here from the original key column is the date column. And now that has been included into the data. So if you have to work with dates from an online Yahoo download, you need to first convert the key column into a date column. So the best way to understand whether a key column is already a column or not is just put the variable name dot shape. That will help you understand how. Is everyone through till here? Yeah. Can I say for value at risk calculations, we need returns? So clearly we need to add another column called as returns column. So how to add a column? So you can write your data set, which is a reference as data, square bracket open, and you can put the new name of the column, whatever you want to put as. So I put it as returns. So this basically is creating a new column in the data set called as returns. So this will be nothing but data dot pct_change is basically a percentage change. In the parentheses, you can give the index. So if I give 1, it will fetch us daily returns. If I put 5, it will fetch us weekly returns, and so on and so forth. Yeah. So returns, can I say, need to be calculated from a certain column, right? So can I use adjusted close or close price column? So if I go on my data set, there is a column on close or adjusted close, right? So you can choose whatever you want to use. We generally use adjusted close. So in this, you have to just reference the proper column from where percentage changes need to be calculated. Yeah, so you can place adjusted close, which is nothing but the header of that column. So if I look at my data set, the header here is ADJ space close. So I will give the same header below that. So if I look at the RHS, I'm taking the adjusted close column from our data set data, calculating percentage changes out of that and storing that in data returns as a new column returns. If I now do data.shape, can I say we have added one more column and the number of columns should reference 8. So now from 7, it's become 8. And now if I look at the data set has a new column called as returns. So later on, we'll be using 3-dimensional arrays. So shape will be rows, columns, comma, number of tables. So that's basically 3 dimensions. Here it's a 2-dimensional data set. So in case of matrix, again, you can use, so if you want to find the number of dimensions, you can use .ndim. Or if you want to see the number of rows, columns, you can use .shape. It should work. Yes, all good. Excellent. Kranti, you did it by yourself. All right. So adjusted closing price, calculate percentage return, and return that output in a new column called as returns. When I do data.shape, there's clearly an additional column added. Now, if you see the first row of returns or of this data set, can you see a NAN not defined? That's because there's no adjusting close before that date, right? So for the first row, always you cannot find, or for the first data, you cannot find returns. So whenever we are using or we are doing var calculations, can I say we need to be careful with this? We need to actually remove this NAN or disregard this, right? So what I'll eventually do is I do not need the entire data set now. What I need is only the returns column, that too after removing the NA part. So I will now store the output in a new variable. So I will not touch my database. I will store the output in a new variable called as returns. And this new variable basically will store data. So you can have data, and then you have the adjusted close. On that, you can calculate percentage change. On that, you can write drop NA. So if there are any NAs in this series, those would be dropped. Yeah. You could have also done data returns dot drop NA, directly working with the returns column. But I'm doing it from the adjusted close column. So instead of 628 rows, now we have 627 rows in the new returns variable. Yeah, it's storing all the returns, daily returns. All right, let's proceed. So can I say the basic requirement is met, returns are there. Now we can start calculating value at risk, right? So the first thing which we will do is quickly let's calculate historical simulation var. So just write. So comments can be used using this hash. Yeah. So you can put a hash. It turns green, and you say, okay, let's start calculating the value at risk. Yeah, this is a comment, so it will not get executed. It will not be compiled actually, just a comment. So for var calculations, can I say we need percentile? Var is a percentile. So percentile is available in a library called as NumPy. So NumPy is where all the mathematical libraries are stored in Python. So you can just import that. No need to install. It should be already preloaded. So you just write import NumPy as NP. So we are saying, okay, let's import NumPy and call it as NP so that we don't have to type the whole thing NumPy dot. We just type NP dot. So it's a shorthand given. It's a mathematical library. So a lot of mathematical functions are in that. Yeah. Array functions are also there inside NumPy. So for instance, if I want to find percentile, one of the ways of doing that is calling up in NumPy as NP and then NP dot percentile we can use. Yeah, so we have the returns. So can I say historical simulation value at risk 99 percentile? So this is my variable. I can give any name here on the LHS. On the RHS, can I say I will use NP dot percentile? And as you can see, it's referencing the correct function. So I can just press tab. And within this, if I go inside this function, it's asking for various parameters. So this is the overview. And if you want to really deep dive into what are the different parameters, you can just, reference this. For instance, we need the array A and we need the percentile, which is not in decimals. It is between 0 and 100. Okay. Don't put 0.1. We need to put 0 to 100. So don't put 1 percentile as 0.01. Put 1 percentile as 1. That is what it means. Yeah. So can I pass the array? On which array do we need to find? The percentile returns array, right? And then I need a 99 percentile var, which means can I write 1 there? So this is calculated. I can just use the same variable, copy paste, and see what values it throws up. So it throws up a value which is basically minus 4.5% is the var of this 99 percentile var. If you want it as a positive value, just put a negative in front of NP. Yeah. So as simple as that. Now, can I say the next? So historical simulation var all clear? Yes. Next, quickly, we will look at parametric var. So just comment it out that a new section is starting, parametric var. And here we can give a variable name, percentile. Yeah. But can I say for the calculations of parametric var, I need the mean, the standard deviation, and something called as a z value, right? So before I start calculating, so we will do this later. So let's first record the mean and standard deviation of our returns. So I can define something called as mean ret, which will store the mean of the returns. So mean ret is nothing but returns dot mean. And then I can just print it out for the output. So this is the mean of the distribution. Standard deviation similarly is returns dot std. So that will fetch us the standard deviation of returns. hash. No need to run it. It's just commented any which way. So anything in green will not be any which ways red. So mean, we have the mean daily return. We have standard deviation, daily standard deviation. Can I say now we can calculate parametric VAR? For that, we need the Z value corresponding to the confidence level, correct? Or the significance level here. So for Z value calculation, we need to call upon a new library, which is the SkyPy library. So you can just type import SkyPy.stats as stats. So statistical functions are part of this. Okay. So can I say for Z value, it is nothing but what is Z value in the case of a normal distribution? Can I say it's norms inverse? So wherever we have to use norms inverse in Excel, we were using norms inverse. So here in Python, we will use something called as norm.ppf. Yeah. So we will use the stats, which we have defined in the library. So stats.norm.ppf, and then you can put in say 1%. If you put in, you get, can I say the Z value corresponding to 1%? Yeah. So let's try doing that. And I saved the output in Z value, new variable. So Z value is stats.norm dot. Yes, you can always verify if you're on the right path because after the dot, it shows the various options which you can use in that object. And here clearly there is something called as stats.norm.ppf. And let's use 0.01 and let's see what value we get. Minus 2.33, which is the Z value for 1 percentile. Yeah. So can we use this now to calculate parametric var? So let's write param var variable equal to, we eventually want a positive value, so we'll go for it later. So can I say, let's write mean return plus Z value into STD return. So Z value is negative, mean is positive, it's a positive drift. It will still fetch you a negative value. And if you want to report it as a positive figure, so just put a bracket minus ahead of the bracket and you can run it. And this is the value, 3.67%. Yeah, so this is the parametric var. And can I say very specifically, it's the 99%. So historical simulation was percentile. Parametric is nothing but mean plus Z sigma. And then finally, there will be MCS. Mean bracket, the function, returns 800. So the final deal is MCS var quickly. So for MCS var, can I say I need simulations? Yeah. and I need to decide how many number of simulations. So let's write nsim, which stores the number of simulations. Let's say maybe you run 1,000 simulations. So we're defining the number of simulations to be run in a variable, calling it as nsim. We've already imported numpy, right? So now what you can do is you can create a new variable called as simulated returns, which let us set to 0. Yes, please. You're taking it from an online source, right? Yeah. So the first step in simulated returns is that we need to create an array to hold these returns. So I call it as simulated return. I put np.zeros, np.zeros, and then I need to give the dimension in terms of what is the size of the array. So we have defined that under nsim as 1,000. Sorry, I've not run the previous one. Yeah, so it creates these new simulated returns. How does it look like? I can just copy this variable name. So it is nothing but an array of zeros. Yeah, so it throws up an array of zeros. What is the size of this array? So the variable name dot shape will give us the size. So 1,000 simulations, right? So our array is ready. The next thing is to simulate what? The z values. So we're going to use this same equation, but instead of z value, here I'm going to use simulated z values, right? For each shock or each row. So how to find the z value? So when we were running simulations, how did we find z values in Monte Carlo simulations? First the rand function, right? So there was a rand function and then inverted, and that gives you the z value, correct? So we're going to do something similar here, which means, can I say the first step will be to simulate random values? For that, again, we will use the numpy library. So you can start doing np.random.rand, and let's keep storing it in the same return, which is simulated return array. So sim return np.random.rand. Sure. So you can also clear the output anytime. So as soon as you go on the output, there's something called as cross here, right? Just cross it out. So the output goes away. You can also delete any cell which you have written. Just right click on the cell and click on delete cell. So that removes that code or that part of the code from your entire set. Can I say I need to give here how many random numbers to be generated? Okay. So once again, I supply nsim. Let's run it and let's see what is the output. Yeah, all good. Okay. Just checking the shape once again, 1000 values. So these are storing all the random values between 0 and 1. To convert, can I say I need to use again the norm.ppf? Yeah. So again, store the return in the same array, sim return. So can I write stats.norm.ppf? And I can give the entire previous output inside there. So let's run it and let's print it. So now if you see, all these are like Z values. Yeah. So this is minus 1.26, minus 1.5, 0.23, right? So all these are your Z values. And once we have the Z values, can I say where we can very easily find the simulated return vector, which is nothing but again storing the output in simulated return. So can I say now we will execute this, which is mu plus z sigma. We have already simulated using rands and then the inverse of that using norm.ppf. So now we do sim return equal to mean return, yes, plus. Can I say the earlier output was stored in sim return, which were the z values? So I will use the same thing here into, yes, standard deviation. So std ret. So all these, so this is the array of simulated returns. And once we have this, we can very easily calculate value at risk. So finally, to calculate MCS var, can I say again, it's a percentile on this new return series, which is the simulated return series. So I will call upon np.percentile. In this, pass the array, which is the new simulated returns array, and give what kind of percentile or significance level. So if it's a, say, 99 percentile, so I will put 1 year. So once again, your percentile always takes between 0 to 100. And this completes your. So you can put a negative for a positive var. So this is your VAR, MCS.